Welcome to my presentation for the first assignment on planning a lesson in physics for year 7. The structure of the lecture is going to be, the content is going to be mainly on friction and dynamic friction particularly. The student will be asked to, before coming to the lesson, to complete a question, a quiz online using Bluecat. And the test will be mainly testing the knowledge, the preliminary knowledge on forces, force balance, and identification of variables. They also will test some of the knowledge coming from stage 3 for science and technology and for math. The lesson structure will be essentially based on 4 stages. The first one is an intro where we are going to describe the friction as a reactive force due to push-pull and to push-pull forces and apply to objects which are in contact each other. Then what we'll show is also some tentative examples where we'll look at, for example, when friction is useful, when friction is a burden, or when, for example, for inclusivity, also how First Nation peoples they actually experience the use and develop technology based on friction. The description of the activity then will be defined by a demo, which the teacher will describe the materials used, the equipment, and some of the methods, particularly highlighting the problems associated with the measurement of the force using the spring balance. Then the student will engage in the practical activity, which will last probably for 20-25 minutes. And during this period, they will repeat 3 times the measurement with 2 different materials on a plane. And and they record the data on a table, which will be provided as an example, and calculate the average across the 3 measurements. And the most advanced students will be engaged with the calculations associated with uncertainties and as a mean value and the standard deviation using, for example, a spreadsheet. And then will follow a 10 minutes assessment task, which will be programmed on Bluecat based on a set of 6 or 7 questions where the student will be asked to provide an insight on the data and the plots that they have obtained using the experimental data. The Bluecat can be set up, for example, using the hack mode, which is a game where the groups of the students they are associated with a password, and each student gets bitcoins based on the correct answers to the questions. But each group can steal bitcoins from another group if they can guess the password of the other group. This is a sort of entertainment at the end of the lecture to make the lecture more fruitful. The lesson that I'm going to present for the assignment is going to be essentially a segment where I'm doing essentially just a recap of the intro, so without going into the detail of the explanation of friction, and then I will show a brief demo of the material, how to use the scales, and how to use the spring balance, and then I will point out to how to establish and what kind of method the student may actually use to improve the accuracy of their measurements. And this particularly I will engage the class proposing to discuss what kind of solution the student may foresee to be able to get the number on the spring balance correct and more accurate with several measurements. So, guys, to recap the concept we saw this morning, friction is nothing else than a force, and exists every time that we have an object which is in touch to a different object, and they share a surface. And the surface has very specific, peculiar characteristics. So based on these characteristics, and based also on the weight or the force that is given by gravitational field on the object, which is push these two objects together, what we will have is a friction which is reactive based on the intensity of the friction of the force that we apply to the object. So if we pull more the object, what we will have is a larger reactive force, which is going to drag essentially our object. So what are the examples that we saw this morning? Is very simple. The idea is that we can have friction is everywhere and it's part of our daily life, but it can be good and it can be bad in the sense that it can be something that we want or something that is in reality creating a problem. Like, for example, if we want to drag a large object across the floor, we need to pull a lot of force because the friction is essentially keeping the object to stay still. And in order to win the resistance, we need to pull more. But for example, if you're driving a car and you want to stop the car, you really need to have a friction. And the friction that you want to have is the one which is in between the tire and the road. And that, or actually the friction which is between the tire and the braking disc that you activate when you press your pedal. But there are also other friction always creates heats, and essentially convert the energy and energy associated with it into heat. So, for example, the First Nations people, they developed in the course of many thousand years a lot of different techniques to use actually friction to generate fire. And these are some of the examples that I found online relative to some of the technology they developed in these many years. Now, what we are going to look at experimental point of view instead is something which I can show you using the camera that is pointing to the equipment, and the camera is showing the material that we have. In particularly, what is important to notice is that instrument. This is called spring balance, and the spring balance shows using this needle shows how much force is required to push and to pull an object. Now, this is essentially the instrument that we can use to identify how much is the force that we need to exert on an object in order to detect the friction. Now, we know that important parameters to define friction is, first of all, the weight of our object. And so what I can show you on the scaler is that I created two blocks of material. One is a plastic, which you can see is a completely transparent, so it's very smooth as a surface. And the other one instead is a block of wood. And the wood and the plastic, they have approximately the same weight, as I can see from the scales. Now, what we are going to do is use also these little weight. These weights, they are approximately 50 grams, and we can use several of them to create, for example, a weight, an apparent weight of our object to be able to mimic that we have more weight associated with it, and how much the friction changes based on the weight. So using this approach, what we can actually do now is look what you will do is essentially look at how and repeat 3 times the dragging of the object across a plane which is made of wood. In this case, the plastic, you can see the needle is moving and it's set approximately at 0.2, but it's also oscillating. You see that oscillation? That actually is a problem, and we will discuss briefly how that happened. And this is actually, this is the example using the block, and you see the oscillation that is induced by the block. Now, how one thing which is important in order to determine friction is how stable is our needle in terms of measurement. And you see the oscillation, they don't help to make an accurate estimation of the number which is defined by the needle. So what kind of strategy do you think we can use to make the measurement more accurate? And can we use, for example, can some of our friends in our group to essentially look attentively to the scale of the spring balance and point with a pen where the needle is sitting most of the time? This could be a way. Another way could be, for example, to approach the problem with technology. Technology can help us to, for example, record the video of the measurement and then going frame by frame, identify what actually is the best value which define the measurement. Now, what you're going to do is repeat the measurement 3 times, and then you are going to add some weight to the block and repeat the measurement again 3 times. At the point, what you are going to be able to do is look at a table, and you can add your measurements. Like, for example, we can start with wood, moving on wood, for example. So we have both wood, and then we have 72 grams is the first weight, the weight of the block itself. And then what we can have is a measurement of the drag, that of the force that we need to apply in order to move it. So we are going to have probably something which looks like that, and then we're going to have different values, and these different values, they are going to give us an average. How we calculate the average? The average is the sum of the values that we have, and then we divide them by the number of samples that we collected. And this is going to be our sample, which is approximately 0.24 in this case.